So recently I posted a video about a math problem, thinking nothing of it, right? I just wanted to talk about this math problem. Well, that video went on to get a lot of views, way more views than my normal videos get. So what the heck, let's run it back and talk about another math problem. This is one that I think is so cool and think about all the time. This problem is referred to as the birthday problem or the birthday paradox. Okay, if I'm in a room with a random group of people, what are the odds that I share a birthday with at least one other person in the room? Let's break it down. Let's say, for example, there are 23 people in the room, including you. You need to figure out how many different combinations of people there could be amongst that group of 23. It's simply 23 times 23 minus 1, or 22. All divided by 2 gives you 253 possible combinations of people. But now, what is the probability that two people have the same birthday in all of those combinations? There could be 1, there could be 2, there could be 23 matching birthdays in that group. Counting up all those possibilities would take a long time. So instead, we're going to flip that. Instead, we'll calculate the probability that everyone in the group has a different birthday. First, we'll look at the probability that just two people have different birthdays, which is 364 over 365, or about 99.726%. If you take that 364 over 365 and set it to the power of the number of combinations we calculated, take that number and subtract it from 1, and you get the probability that two people in that group will have the same birthday. So if we plug in 253 combinations, we get 0.4995. 1 minus that means that in a random group of 23 people, there's a 50% chance that two of them have the same birthday. I first came across this problem years ago when I was watching an episode of NCIS Los Angeles where they did a slight crossover with the original NCIS. Abby came out to LA because she heard about a case they were working on and thought it was linked to a serial killer that she was tracking. Except no one else thought that this serial killer was actually real because all of the cases that were supposedly linked to them were completely different victims, ages, races, all of that. There was no consistent factor. They had no MO. They never repeated the same kind of victim twice. True randomness does have patterns, so to compile this group of people where they didn't have one single aspect in common was really impressive, because even when you do everything that you can to take out any possible patterns, nature is going to come in and create some sort of pattern. It's unavoidable and really, really hard to, again, just achieve no common ground whatsoever. Anyways, that's another one. I thought it was cool, and I hope you enjoyed it as well, and we'll see how this video does. I might just have to keep posting math content.